Hey there, data science enthusiasts, welcome back to my channel. In today's video, we'll continue diving into the fascinating world of machine learning. We'll explore the different types of machine learning, get ready to expand your knowledge and see how machine learning is transforming various industries. Let's get started. In the last video, we discovered three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. We'll define each type and depict it with an example. So let's start with supervised learning. It's a method in machine learning where we teach the model using labeled data. Labeled data means each input comes with the correct output. Here's how it works. First, we collect data. Then, we label the data with the correct answer. Next, we use the labeled data to train our model. Finally, we use the trained model to make predictions on new unseen data. Let's look at an example: email spam detection. We collect a bunch of emails and label each as either spam or not spam. Then, we use these emails to train the model, and then it can predict whether new emails are spam or not. There are two main types of supervised learning: classification, where we categorize data into classes, and regression, where we can predict continuous values, like for example, predicting house prices. Unsupervised learning is a method in machine learning where the model is trained on data that isn't labeled. This means we don't provide the correct answer to the model. Instead, the model tries to find patterns and structure in the data on its own. Here's how it works. First, we collect the data. Then, we input this data into the model. The model processes the data and tries to find patterns or groups within it. Finally, we analyze the result to understand these patterns. Let's look at an example: anomaly detection in network security. We collect data on network traffic patterns and user behavior. We input this data into the model, which then identifies unusual patterns or anomalies that could indicate potential security threats. Unsupervised learning can be broadly categorized into two main types: clustering and dimensionality reduction. Clustering involves grouping data points based on their similarities, with customer segmentation being a prime example. Dimensionality reduction focuses on simplifying complex datasets while retaining their essential features. One of the most widely used techniques of dimensionality reduction is principal component analysis, which helps in reducing the number of variables in the dataset. Now, let's move into reinforcement learning and find out how it works and what it's used for. Reinforcement learning is a method in machine learning where an agent learns to make decisions by performing actions in an environment and receiving rewards for those actions. It means the model learns to make decisions from interactions and through feedbacks. Some applications are autonomous driving cars, robotic trading, and gaming. Reinforcement learning is much like early childhood learning. A toddler observes something, takes an action, receives positive or negative feedback, and then adjusts their future behavior accordingly. Reinforcement learning, along with unsupervised and supervised learning, forms one of three major branches of machine learning. While unsupervised learning aims to identify unknown patterns in unlabeled data, and supervised learning focuses on learning patterns from previous labeled data, reinforcement learning tackles two distinct objectives. First objective is discovering previous and known solutions to existing problems, such as a machine that can play chess better than any human. The second objective is finding solutions to problems that arise from unforeseen circumstances, like a machine that can find alternative route after a mudslide has blocked the expected path. Reinforcement learning involves two primary entities that continuously interact with each other: the agent and the environment. The agent takes action to interact with the environment, which then responds by providing a feedback or observations. This feedback comes into two forms: state and reward. The state describes the impact of the agent's previous actions on the environment and indicates the possible actions that agent can take next. Each action is associated with a numeric reward, which the agent receives based on the action taken. The agent's main objective is to maximize the cumulative reward it receives over the long term. To illustrate how reinforcement learning works, let's imagine a robot, the agent, navigating a 3.3 grid to reach a goal. The robot starts at the top left corner, and the goal is at the bottom right corner. The robot can move up, down, left, and right. If the robot reaches the goal, it gets a reward. If it moves into a wall or stays in the same place, it gets no reward. The robot task is to learn how to reach the goal in the fewest steps possible. The robot starts at 0.0 and then it moves right to 0.1. The robot is now at 0.1. It receives 0 award because it has not reached its goal yet. Now, the state of the robot is at 0.1. The robot moves down to 1.1. Now the robot is at 1.1. The robot receives 0 reward because it hasn't reached the goal yet. Again, the robot is at 1.1. The robot moves down to 2.1. So it is now at 2.1 and it receives 0 reward because it hasn't reached the goal yet. Now the robot can move right to 2.2. The robot reaches the goal at 2.2, so it receives a reward of +10 for reaching the goal. In this example, the robot learned to navigate the grid to reach the goal by receiving reward. The state represents the robot's position on the grid, and the actions represent the robot's movement. The robot's objective is to maximize the total reward, which it does by learning the best sequence of actions to reach the goal efficiently. Thank you for watching. We've covered the essential type of machine learning today, including supervised, unsupervised, and reinforcement learning, along with few key examples of each. I hope this overview has provided you with a solid understanding of how these techniques and their practical application. Don't forget to like, subscribe, and hit the notification bell to stay updated with more insightful content on data science. If you have any questions or topics you'd like me to cover in future videos, leave a comment below. See you next time.